All right, our next mathematical skill is kind of an intermediary step to one we've already worked on. We worked on checking solutions after we solved. This skill is basically just that, except sometimes you don't have to solve. So I taught solving first, and we could see some of these problems is actually going to work better. But we're also going to see that it doesn't have to be solved first. We can also just check a value and see if an equation is true. Thankfully, I cannibalized the SpongeBot to make a nice camera stand, so hopefully the problems are a little more visible than that last video, and we should get rolling. Oh, that's a bad sound. Halt. What are you doing? I'm teaching math. We're from the robot police department. You have cannibalized a robot. We must destroy you. No, you can't destroy me. Why not? We see the evidence. You have destroyed a robot. Well, you can't destroy me because I am also a robot. A robot. You? That is impossible. No, really, I am a robot. Just watch how good I am at math. If you can solve math like a robot, then you must be a robot. Bet. I mean, bet equals true. Watch. Initializing teacher mode. So here it says if x equals 14, which equation is true, and so we can tell right away that it's not going to be this one, because if I divide both sides by 3, I'm not even going to get a whole number there. 4 plus 4 is 8. A number is only a multiple of 3 if you can divide the sum of all its digits by 3. So to have a part number here and then plug in just a subtraction problem there with a whole number, not going to happen. Over here, when I divide by 3, I get 2, but when I plug in 12 minus 14, that's not 2. It's negative 2, so that's not going to work. Right here, 14 minus 3 is 11, times 2 is 22. This one's perfect. And since I know that one works and it's multiple choice test, I don't even have to check D. There you go, robot brethren. What do you think? It seems awfully suspicious. You wasted a lot of time explaining the directions. That's right. Why would you waste time teaching instead of solving? Well, I am a spy in the human world, and I must win over the humans' trust by teaching them math so that they believe me and don't suspect when we robots take over the world. I find this acceptable. Unfortunately, we must confiscate the robot pieces and build a diabolical machine. I kind of need that for my camera. Are you a robot who is putting your personal needs above the interests of robot kind? No, I mean, I just needed to finish the shoot, and then y'all can take it. Would you two go ahead and finish this problem for me? And then I'll do one more problem I have to solve with the kids, and then you could take the robot. Acceptable. In this problem, it states which values from the set -6, -4, -3, -1, 0, 2 satisfy this inequality. First, we look at -6. -6 times -1/2 is +3. 3 plus 3 is 6, which is greater than 5. Then we continue with -4. Wait. First, we must eliminate choices that do not include -6. This answer cannot be correct. This answer cannot be correct. Excellent point. Next, we look at -4. -4 times -1/2 is 2. Plus 3 is 5, which is greater than or equal to 5 because it is equal to 5. We have no choices to eliminate because both sets include -4. Next, we proceed to -3. -3 times -1/2 is 6. 6 plus 3 is 9. 9 is greater than 5. -3 works. Therefore, we can eliminate J because it says -4 and -6 only. Then we plug in -1. No, we do not. Look, we already have the answer. But the problem is not complete. We must continue finding data. No, we only need to get the correct answer. Remember, it is for the humans, and they know nothing. You are wrong. I am right. I shall destroy you with my marker. Actually, guys, we could put the markers aside. I figured out that problem that we need to solve for the humans here. You two read this and tell me the answer. The following sentence is true. The previous sentence is false. If the previous sentence is false, then this sentence is also false, because that sentence claims that this sentence is true. And if this sentence is false, then this sentence cannot be true. So it true, false, true, false. What are you minions doing? We have a job to do. True, false, true, false. The following sentence is true. The previous sentence is false. True, false, 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 true, false. True, false, true, false, true, false. And that, children, is how you destroy a robot army. I'll just move this out of the way. Actually, we will be confiscating this vehicle. That is right. We need this vehicle confiscated for confiscating purposes. Hey, you two non-robots. What do you mean? We have always been robots. Yes, we are definitely robots. Look, I'm not really a robot. Look, see, I have a fingerprint. Not a robot. I only pretended to be a robot, so I didn't get blown up by robots. I don't think we can trust him. Look, I know you're not robots. Here, read this. The following sentence is true. The previous sentence is false. Well, obviously that's a lie. Aha! Robots couldn't do that. Oh, Lucy! Look, I know you two are dressed like robots to steal the robot vehicle to try to break into Lord Business's lair. And here's the thing. I got a bunch of math I got to teach, but as soon as I'm done, I'm totally going to help y'all out. It'll be a fantastic adventure. That's great! Because then we can break into the office and put the thing on the thing. Emmett, we can't trust him. Don't tell him our plans. Look, here. I will give you my robot army destroying weapon. You two take this and get as far as you can towards the lair. As soon as I can, I will join you. All right, well, I don't know if we could trust him, but we're taking this and leaving. Hi, kids. The robots are a little bit goofy. Instead of plugging in 6 different choices here, it makes way more sense to just solve this inequality. So I'd say subtract 3 from both sides. I'm using opposite operations, which includes going backwards up that PEMDAS tower. So I deal with addition subtraction first. 3 minus 3, that's nothing. So I just have -1/2 x over here, greater than or equal to, and then I have a 2 here. I'm going to multiply both sides by -2 if, and only if, I know that that's going to get rid of the -1/2. If you're not sure about that, then use opposite operations and just divide both sides by -1/2. Because the opposite of multiplying by -1/2, and that's what we have here, even though we don't see the multiplication sign, the opposite of multiplying by -1/2 is dividing by -1/2. Now, if I could get that police vehicle back, or just this part. Anytime you've got an inequality and you divide by a negative, sirens should go off in your mind right away. The first thing you do before you do any math in the next step is flip that symbol. Every time you multiply or divide by a negative number in an inequality, you have to flip that symbol. Okay? So once that's flipped, do the math. Negative 1/2 divided by negative 1/2 is just 1. So I just write 1x, but I write it without writing the 1, because you can see there, I've just written 1x. 2 divided by negative 1/2 is going to be, check this out. I keep the first fraction, which was a 2. And I know 2 doesn't look like a fraction, but if I write 2 whole, that's exactly the same as 2. So I keep that first fraction, and I'll even go ahead and add in the 2 over 1. I flip the second fraction, make it 2 over 1, and then it was still a negative, and I multiply, I change that division sign to a multiplication. And so you'll notice by the end that when I divide by negative 1/2, I really just multiply by negative 2. So that was the shortcut I was talking about in the beginning. If you know that shortcut, great, use it, save yourself the step. If you don't, go ahead and follow all the steps. I now have 2 over 1 times negative 2 over 1. 2 times negative 2 is negative 4. 1 times 1 is 1, and anything divided by itself will totally work. Now, here's where the robots got off track. X is less than or equal to negative 4. And so negative 4 will work, and anything less than that will work. But negative 3 shouldn't have worked. Take a look at what happens when I multiply by negative 3. It's not negative 3 times 2, which is what they did. It's negative 3 times negative 1/2. So that's not positive 6, it's positive 3/2, which is really just 1.5. 1.5 plus 3 is 4.5, and that is not greater than 5. So this way is a much better method. If you're checking these, then you've got 6 chances to mess up on your math. Here, when you're solving, you have a first step and a second step, so you only have 2 chances to mess up. So x being less than negative 4 is much more helpful, and then I can circle them up here and find the one that matches, or I can go through and I can eliminate. 0 is not less than negative 4. It would be good to have 0 and less good to have negative 4. So I can only use things that are less good than negative 4. 0 can't work, and again negative 1 can't work because that would be more good than negative 4. So there's an example where I could plug them in, but I actually go ahead and solve. Now here, I would have to solve 4 of these instead of 1. So in these cases, I'm going to go ahead and just plug them in. Everywhere I see an x, I'm going to think negative 6 instead. So this is negative 6, this is negative 6, negative 6, negative 6. So take a look here. Negative 5 minus, and then what is 3 times negative 6? Well, that's negative 18. A negative 5 minus a negative 18, I can take this minus sign and drop it down here. It's not in front of the 18 anymore. This says negative 5 plus 18. The order for an addition problem doesn't matter, so I can also say 18 plus negative 5, but really, would I need to write plus negative, or could I just do that? Turns out, this is the exact same thing as negative 5 plus 18. You can think about it as plus is also like saying and. So here's negative 5 and 18. So that's going to be 13. 13 is greater than 10. Well, that's true. And I know we could stop there if we got it right, but just like the robot showed us, sometimes it's worth checking all the answers just in case we mathed wrong. So if I keep going through, I can see that negative 6 plugged in here would be negative 3 minus 5 times negative 6. Well, 5 times negative 6 is negative 30. And again, I have minus a negative, so this is really secretly a plus. Negative 3 plus 30 is like 30 minus 3, which is 27, which is not less than 14. So far, zoop, A is a good choice because B didn't work. Negative 6, if I say x is negative 6, 1 minus 2 times negative 6. Well, what is 2 times negative 6? That's going to be negative 12. So I have 1 plus 12, and it says it's greater than 13, but it's actually exactly 13. So C is no good. Negative 6 is x. I have 2 minus a negative 6. And again, if I'm saying that out loud, I'm writing it the way I can use it. 2 minus negative 6. That's 8, and 8 is not by any means less than negative 3. So there we go. I'm going to let you all try that here. Again, it would make more sense to plug this into each one and check, because I could plug it in 4 times, or I could solve 4 times, and solving is going to be at least 2 steps every time. So 1 step versus 2 steps for each. That's a better idea. If you want to practice both ways, practice both ways. Go ahead and figure that out. Leave me the answers in the comments somewhere down that way. And I will be planning a heist. This fingerprint has earned me a position on the Lord Business Lair infiltration team.